Good day, everybody. So today I'm going to discuss about length of a parametric curve. So in length of a parametric curve, we need to consider these formulas that we have here. So if your x or your parameters or the curves or the parameters of the curves will be in terms of t, where x is equal to f of t and y is equal to g of t. So you need to make use of this formula. Right? This is L is equal to the integration of square root of dx over dt quantity squared all plus quantity dy over dt quantity squared dt from your a to b, right? And if your x and y is ang function niya or one variable niya is in an angle or in theta, that's x equals to f of theta, y is equal to g of theta. So you make use of this formula to solve for the value of the length of this parametric curve is equal to the integration of the square root of d quantity dx over t theta quantity squared plus dy over t theta quantity squared d theta from your theta 1 to theta 2, which is maybe could be alpha to beta. So let's try to answer this example here or some examples here that help you to understand what is a parametric curve. So let's try to compute the length of the curve where one of the parameters of this length will be x is equal to 2 cosine squared theta, and then our y is equal to 2 cos theta sine theta, where our theta here is from 0 to pi. So we need to get the length with these parameters that we have. That first one, x is equal to 2 cosine squared theta and y is equal to 2 cosine theta sine theta. Then from our limits is from 0 to pi. So you don't need to draw it because we are given na sa mga parameters na naata. So we have to solve for the value of L, where L is equal to the square root of, equal to the integration of the square root of dx over d theta, right? Quantity squared plus dy over d theta quantity squared times d theta from your alpha to beta. So let's find the value of dx over d theta and dy over d theta, and then let's try to square it para diretso na lang tayo substitute later. So we have let's start with x value first. So x value is equal to 2 cosine squared theta. So we need to find the first derivative of it, and then we will square it. So this is equal to 2 cosine theta. Then derivative of cosine theta is negative sine theta, right? D theta, right? It's d theta. So we just simply rewrite it na lang. This is equal to negative times 2. Sorry, by times 2 pala. So we have negative 4, right? Cosine theta sine theta. And then dx over dt, d theta, quantity squared. This is equal to negative, we have 16 na lang. 16 cosine squared sine squared theta. How about for our y? We need to get dy over d theta. So y is equal to 2 cosine theta sine theta, which we will apply the product rule in derivatives. So that's u dv plus v du. So this is dy over d theta. Then this is equal to 2 cosine theta. Then derivative ng sine, that is just cosine theta plus 2 sine theta. Then derivative ng cos, that's negative sine theta. So we just simplify the expression here. We have 2 cosine squared theta minus 2 sine squared theta. Then we will try to get the dy over dt theta quantity squared. So this is equal to your product rule lang. This is, product of binomial. So this is equal to 4 cosine to the 4th power theta, right? Minus 8 cosine squared cosine theta, cosine squared theta, sine squared theta, right? It's plus 4 sine to the 4th theta. So by that, we already have our dx over dt, and d theta dy over d theta, and then d square na to, pwede na to siya i-substitute dali. So let's find for the value of L, right? For L is equal to the integration of square root of, just simply substitute dx over d theta quantity squared, which is 16, cosine squared theta sine squared theta, right? And then dy over d theta, that's plus dy over d theta squared, quantity squared, this is 4 cosine to the 4th power t theta minus 8 cosine squared theta sine squared theta plus 4 sine to the 4th theta, right? So let's try to simplify the from your alpha na 0 to pi, right? Let's try to simplify the radicand that we have, that this is equal to 8 cosine squared sine squared theta, right? Plus sine to the 4th, right? 4 sine to the 4th, sine to the 4th theta plus 4 cosine to the 4th theta, d theta, right? That's d theta. Okay, d theta here. So we will have to factor out 4. So that's square root of 4, which is 2. So I'll just put 2 here. This is 0 to pi. Then we have now 2 integration of square root of, right? With this one, you factor out naman na to si 2 daw, that this becomes, si 4, sorry, this becomes 2 cosine squared, right? I'll just write, arrange na lang ako daan. This is equal to sine squared theta plus 2 sine squared theta cosine squared theta, right? Then plus cosine to the 4th theta d theta, right? So maybe we could apply our algebra here, the laws in special products in algebra. So if we will have this kind of given that we already know that it could be simplified to the expression quantity cosine to the 2nd power theta plus sine squared theta quantity squared, but this is 4. Sorry, this is to the 4th. So let's have it here, right? But the given expression kanina, it will be simplified to the value of L now is equal to the square root of, from 0 to pi, to L is equal to 2 integration of square root of, it will be simplified to cosine, let's try to have sine first. What was sine squared theta, right? Plus cosine squared theta quantity squared d theta, right? So your expression kanina will be simplified to this expression, right? By applying some algebraic rules, some special product rules. So by that, right? So we already know that this value here is equal to 1. So we will have left na L is equal to 2 integration of square root of 1. And square root of 1 is 1. You just left by d theta na lang, 0 to pi. So L is equal to 2 times the quantity of theta na lang. So let's try. Let's integrate it. First, we have theta. Oops. theta from 0 to pi, and this is equal to 2 pi minus 0, so we will have 2 pi. This is the length of the curve. This is the final answer. Now let's move on to the second problem that we have. So let's have number 2. Let's try to compute the length of the curve x equals to t sine theta, y is equal to t cosine theta from t is equal to 0 to t equals to 2 pi. So we have here the parameters and our limits, so we don't need to draw na lang because we tayo natanan. So we have to find the value of our length of this parametric curve. So we have length is equal to the square root of dx over dt quantity square plus dy over dt quantity square d times dt from your a to b, where your a here will be 0, b will be 2 pi, and dx over dt, that's the first derivative of your x and the first derivative of your y for dy over dt. Now let's try to find dx over dt first, and then let's try to square it para substitute na lang natin. So where x is equal to t sine t, which we need to apply the product rule in derivative, that's u dv plus b du. So let us have t cosine t, right? Plus we have sine t times 1, so that's sine, right? So that is dx over dt. Now let's try to find the value of dx over dt, right? Dx over dt quantity square. So this is equal to t squared cos squared quantity t plus 2t sine t cos t plus sine to the second power t, right? How about our y value, which is, this is equal to y is t cosine quantity t, and then dy over dt, this is equal to t, right? This is sine t, this is negative sine t plus t then times 1, right? And this is equal to dy over dt. So this is equal to square the first term, that's t squared sine t, right? Minus squared ito, minus 2t sine t cosine t, right? Minus, we have plus ito, plus, right? Plus cosine squared t, right? So we have this na as our dy over dt quantity squared. Now we will substitute this to our equation. So our equation, let's substitute it. Now we have L is equal to the integration of the square root of this one, our dx over dt quantity squared, which is equal to this term here. So we have t squared cosine squared quantity t, right? Plus 2 sine quantity t cos t, right? Plus sine squared quantity t. Then we have another one. We have here plus the quantity of dy over dt quantity squared, which is equal to t squared sine squared t minus 2t sine of t and cosine of t, right? Plus, write the plus the quantity plus cosine squared t. So maybe we could cancel out this one and also this one, right? We have left times dt from 0 to 2 pi, right? So this is equal to L, which is equal to the integration of the square root. So pa itong pwede simplify. Oh, of course, sine squared t and cosine squared t is equal to 1, right? So we have left na t cos t squared cosine squared t, then plus t squared sine squared. This is sine squared t and plus 1, right? So with that, maybe we could try to change another value here. Maybe we could factor out t, right? Okay, this is dt. T squared. Then this is equal to cosine squared quantity t plus sine squared quantity t plus 1. Right? With this expression lang. So this is, this is equal to 1, right? Times dt. So from 0 to 2 pi. So we have L is equal to the integration of, ang nabili na lang na to is t squared times 1, which is t squared, plus 1 dt from 0 to 2 pi, right? Now we need to make use of our methods of integration here. Maybe we could make use of the tangent, right? I mean, trigonometric sub, pwede po na to gamitong on anything. So let us have t is equal to tan theta and dt, right, is equal to secant squared theta d theta. So we will have to substitute it. Maybe let's try to change the limit in terms of theta. So we have, if t is 2 pi, t is equal to 2 pi, we will have theta is equal to arctan of 2 pi, right? So if t is equal to 0, theta is equal to 0. Let's try to substitute it. This is equal to the integration of square root of, this is secant tangent squared, right, theta plus 1 times d theta, which is secant cube theta d theta, from 0 to arctan of 2 pi. So we have here, this is equal to secant squared. So we have secant squared theta times secant squared lang ito, right? Secant squared theta, d theta, from 0 to arctan of 2 pi. So we will have here secant to the cube theta d theta from 0 to arctan of 2 pi. Right? So now we need to integrate it, but I think secant cube theta doesn't have any direct integration, but I think we already solved this in our previous problems. or on your activities, and this value here, second cube theta d theta, is equal to 1/2 sec theta tan theta plus ln of secant theta plus tan theta, right? From 0 to arctan of 2 pi, right? So let's just simply substitute the values. We have 1/2. Now let's try to substitute the values that we have. This is equal to 1/2, right? Let's try to change secant theta to the value in terms of tangent. So this is equal to, from here na lang, square root of 1 plus tangent squared theta, right? Times tan. Para dali na lang ta mag-input sa calculator, plus ln of square root of, let's try to change it in terms of tangent. This is square root of 1 plus tangent squared theta plus tangent theta, right? From 0 to arctan of 2 pi, right? That's arctan of 2 pi. So we will have, okay, I'll just try to write it much clearer. This is arctan of 2 pi, right? So let's try to substitute these values first in this term na lang. So we have 1/2, and this is equal to the square root of 1 plus, this is just 2 pi. Arctan of 2 pi is equal to around 80.95 something. Then i-can na po din mo siya mabalik, yapon siya sa 2 pi. So we just have 2 pi squared here, right? Same thing, times 2 pi plus ln of square root of 1 plus 2 pi squared, quantity squared, plus 2 pi, right? Then we will have, this is 0, right? Pag 0, substitute na to 0, tan 0 is 0, and then we will have here ln of 1 is 0. Kasi may ln of 1 po dere pag i-0 ni mo ni kanina term. So this is tan 0 squared, this is 0, then we have ln square root of 1, that's still 0, right? Try to input this in your calculator, you will get 21.256, right? That's the length of this parametric curve units. So I think this is the end of my discussion video for parametric curve. So I will upload new videos for surface of revolution and also for the centroid.